All right, guys, so this is going to be a quick overview on isotopes. Not a lot here today. I would suggest writing down what's highlighted in gray, and then obviously the practice, I would write that down as well. That was a little harder to highlight in gray, but I'll kind of talk you through that as we go through. So hopefully you've completed the isotopes POGL already and know a little bit about these. So this will kind of just be a quick overview, kind of what you saw, what you hopefully realized, what you recognize, so we can go ahead and get these moving forward. These are directly related to that problem solution that you're going to be completing. Remember, problem solution, we're trying to help identify and exemplify and illustrate isotopes, stable isotopes of your given element. So this will be kind of what you're, one of the pieces that you're responsible for. So what are isotopes? Isotopes are two atoms of the same element and they have different masses. So remember that we talked about in the first set of notes that atoms, if they're the same, they have the same number of protons. That cannot change, but what can change is the mass, and that's going to be changed by that number of protons. By the number of neutrons. So that's going to be what's changing our masses, and that's going to be different in our neutrons. So here's an example, pretty common one. Carbon-12, the most common carbon in the universe. On the periodic table, the atomic mass or the average atomic mass, the relative abundance of carbon is about 12.011, which means most of the carbon that you find is carbon-12. But there are other isotopes, notably 13 and 14. 14 is probably the most popular just because of carbon dating. But what is different is not the protons. Protons are the same. They both have 6 protons. But the number of neutrons is different. You'll see the number on the right has more neutrons, which are the white, while still having the same number of protons, which are the red. You write isotope symbols a specific way. So you'll have the element, and that's just a variable there, X. There is no element X, but you can put any element symbol in there. And then if I ask you for an isotope symbol or you see an isotope symbol, what you're actually seeing is the atomic number on bottom. Remember, that's the number of protons. And then the mass number on top, both of these to the left. And remember that the mass number is protons plus neutrons. You can also see them sometimes on the right. I will not be putting any of those on the right, but some sources will have those on the right. Same thing, atomic number on bottom, mass number on top. But I will hold the right for charges and things when we get to ions. Most commonly, you see them on the left. So a quick little practice. I would see if I could pause here and see what you can figure out based on what we just talked about. So here's an element fluorine and an atomic number of 9 and a mass number of 19. So pause here for just a second, or if you can just do this real quick in your head, you may not even have to pause it while I talk. And see if you can answer the following. So it says find the number of protons, number of neutrons, and the number of electrons. We talked about electrons or atoms for right now being electrostatically neutral. So I'll go ahead and tell you your number of protons, your number of electrons for right now should always be equal. That will change a little bit when we move forward some more. But take a second and see if you can figure that out. I'll give you a second as well. Hopefully you were able to figure out that the number of protons was 9, the number of neutrons was 10, because your mass number minus protons is your number of neutrons. So 19 minus 9 gave you 10. And then your number of electrons, like we said, for right now, they're going to be equal to the number of protons, which is also that atomic number, which is 9. A little more practice solving for numbers of neutrons. I would pause here. Write these down for sure, as well as that last one. Make sure you get that last one down. But this is just a couple more practice problems of calculating the number of neutrons. It's just simply pretty easy. Little subtraction. But take a second and see if you can figure these out. I'll give you just a second as well. Maybe if you're quick at math. Otherwise, pause it. For sulfur, you got 32 minus 16, which gives you 16 neutrons. For Ag, which is silver, you got 108 minus 47, which is 61 neutrons. For bromine, Mass number of 80 minus the atomic of 35 gives you 45 neutrons. And oxygen, 16 minus 8 gives you 8 neutrons. So all you're doing there is when you see a set of numbers beside an element symbol in that fashion, that's just going to be subtraction to find neutrons. It's going to be one of the pieces of the puzzle that you'll see here in just a second about the larger type of assessment that you will see with this. And that's going to look something like this. This is going to change. This is going to grow a little bit as we keep learning in these first couple of sections. But this is just, can you do this over and over and over, a couple different times, a couple different numbers, given a couple different numbers, not given some other ones. So it just kind of depends on what you're given here, but you can figure out all of these, filling in the blanks and assuming that neutrality. Make sure you take that into account. That's going to help your proton and electron number for now. But see if you can take a few minutes. I would definitely write this down. I'll be looking for this in the notes for sure, that you have to submit, and see if you can work through these and get all of these. I'll give you a minute to pause here. This might take you a few minutes, so I'm not going to wait a few minutes. So go ahead and pause. See if you can knock this out. See if you get what we're doing so far. Again, very quickly, your atomic number and your proton number right now are always going to be the same, but right now so is your electron, so that should have been helpful. Your answers, I know it's a little harder to see the white ones there. Let me see if I can zoom in, that would be helpful. Okay. There we go. That might make it a little bit easier. So hopefully you got the atomic number and the proton number being the same. So you were given the white values. They just were black and turned white here. The red ones are what you should have been able to fill in. So knowing your atomic number, that gave you your proton number and your number of electrons. And the second one, knowing your protons, gave you atomic number. And it also, your mass number was your proton number plus your neutron number. Your next one, you were given these numbers here. So your electron number was really the only indicator you needed because your electrons are your protons for right now. They are equal. And then your atomic number as well. The next one, you were given these three. So your atomic number gave you your proton number, which was also your electrons. Pretty much the same as the last one there. The next one you had the proton number, which gave you your atomic. You had the mass number. You could take that mass number and subtract your atomic number and get your number of neutrons, which was 35. And then your electrons were there. Those are equal to 30. And then finally, that last piece, you had mass number and neutrons. So you could subtract those two and get your protons. So 74 minus 41 gave you 33. And then that number indicated your number, or your atomic number, which was 33, as well as your number of electrons, which was 33. So this is something we're going to do when I see you next. This is going to be a great indicator of you getting this. This will be something you definitely see moving forward. We will definitely add to this as we proceed through this first problem scenario for sure. And this will be a great way that you'll be assessed in this first problem scenario. So that was a quick look at isotopes. Make sure you turn in your notes. This should be the end of part 2. Make sure you turn in the notes, making sure that you include all the practice from within here, especially this last chart. And you have a great day.